Good morning to all of you. Welcome to my class. Before begin, we tell you today we are going to discuss some theory and questions to the chapter sequence and series. It is the most interesting and most easiest chapter in mathematics. Let us start today's class. Today's theory is inserting n GMs between A and B. Let Z1, Z2, Z3 Zn be the n GMs in between A and B. Suppose A here, B here. That means this is in GP. So there are n GMs, therefore n plus 1, therefore this is equal to n plus 2th term. Therefore we get T2 Tn plus 2. That means T plus 2th term of GP is equal to, we know by formula, A into R to the power n plus 1. Since it is n plus 2, therefore it is n plus 1. And this is equal to given B. Since we know Tn is equal to A into R to the power n minus 1 in GP. That is the nth term of a GP. This is equal to, you can write R to the power n plus 1 is equal to D by A. Therefore, you can write R is equal to B by A whole to the power 1 by n plus 1. That is the common ratio of this series is R. R is given by B by A whole to the power 1 by n plus 1. Now to find the GMs, that is Z1. Therefore we get Z1 is equal to what? Z1 is nothing but second term. That is Z1. That is the second. That's the first term, the second term. That means T1. This implies you can write AR is equal to A into R is equal to what? B by A whole to the power 1 by n plus 1. Similarly, Z2, that is that Z2 is equal to third term, that is T2, that is T3, that is T2, sorry, is equal to AR square, this is equal to A into B by A whole to the power 2 by n plus 1. In this way, we can find Zn is equal to what? Zn plus 1 is equal to AR to the power n. This is equal to A into B by A whole to the power n by n plus 1. That is the last GMs in between. That is the GMs. With this we can find the GMs between A and B. That is the inserting n GMs in between A and B. That is the theory. Some small questions, very simple questions. Insert 5 GMs between 2 and 128. Find the last GM. By theory, here A equal to what? 2, B equal to what? 128, and n equal to how many numbers of GM? 5 GMs. Therefore, last GM means Z5 is the last GM. Last GM equal to what? Last GM is equal to what? T6. T6 is equal to what? A into R to the power 5. Since Tn equal to what? A into R to the power n minus 1. This is equal to what? A equal to 2. B, R equal to what? R equal to B by A whole to the power 1 plus n plus 1. Therefore, R equal to what? B means 128. A means 2 whole to the power 5. 5 by n means 6. 5 plus 1, therefore 6. Therefore, we get 2 into this is equal to 64 into 2 to the power 2, 4, 8, 16, 32, 64, 6 into 5 to the power 6. This is cancelled. Therefore, 2 into what? 2, 4, 8, 16, 32. This equal to 4, 64. That is the last GM. Very simple question. That the last GM is equal to 64. That is the. To discuss the product of n GMs. N GMs. Let the GMs are G1, G2, G3, Gn between A and B. Already you have discussed here R equal to what? Already you have to find earlier theory. R is equal to what? B by A whole to the power 1 by n plus 1. G1 equal to what? G1 equal to, that is G1 is equal to T2. T2 is equal to what? AR. AR is equal to what? A into B by A whole to the power 1 by n plus 1. Or G2 is equal to what? T3. T3 is equal to what? A into R square. Similarly, G3 is equal to what? T4. T4 is equal to what? AR to the power q. In this way, we get Gn equal to what? Tn plus 1 is equal to what? AR to the power n. Therefore, product of Gn, consider this equal to P. That is, P means product of Gn. That is G1, G2, G3 dot Gn. G1 equal to what? AR into AR square into AR cube dot AR to the power n. If we multiply this, then we get P is equal to what? AR to the power 1 plus 2 plus 3 plus 4 plus dot equal to n. This is equal to what? A equal to R to the power n into n plus 1 by 2. That is the sum of natural numbers. That is 1 plus 2 plus 3 plus dot n is equal to what? Summation, and that is the special series. That is n plus 1 by 2. That is the concept of the special series, sum of the special series. Now put R equal to what? R equal to what? R equal to what? B by A whole to the power 1 by n plus 1 whole to the power what? N plus 1 by 2. These are cancelled. Therefore, we get right here, and P is equal to what? We get A into B by A whole to the power n by 2. This equal to what? A to the A into B to the power n. That is n. A to the power n, B to the power n by 2 into A to the power n by 2. This equal to, we get A to the power n by 2 into B to the power n by 2. After cancelling, this equal to what? A B whole to the power half whole to the power what? N. This equal to root over AB into whole to the power n. This is equal to Z. That is the Z is the GM between a and b. There is a single gn, therefore we write g to the power n. That is the product of n gm is equal to g to the power n, where g is the geometric mean between a and b. That is the theory. That is the we get product of the n gms is equal to root over ab whole to the power n, or g to the power n, where g is equal to what? G is equal to root over ab. That is the gm of ab. Very simple problem, theory related. That is the product of n gms. That theory related question is this. Here find product of 5 gms in between 5 and 125. Here a equal to what? 5, b equal to what? 125, and equal to what? Number of gm equal to 5. Since product of 5 gms is equal to p, that means you can write this gm1, g2, g3, g4, g5. This equal to what? G to the power n. What is g? G to the power not than 5. What is g? G is equal to root over ab. This is equal to root over 5 into 125. This is equal to root over 625. This is equal to we get 25. That means g is equal to what? 25 whole to the power 5. This is equal to we write 5 to the power 2 whole to the power 5. That means 5 to the power 10 is the product of 5 gems. That is the reason. Discuss one theory that is known as the arithmetic geometric progression. This is AGP, arithmetic and geometric progression. This progression is like in this way. Each term of arithmetic and geometric progression is the multiple of AP and GP. That is A R plus A plus B R square, comma A plus twice D R cube dot. It is known as the arithmetic geometric progression. Why? Each term, that is the first term, is the product of what? A R, that is A plus D, A plus twice D in here, A plus D, A plus twice D is in A, and R square, R cube, dot, is a G. That is each term of this series is the product of two series, that is one is AP, other is GP. Here one is AP, other is GP. Here one is AP, other is GP. So this series is known as the arithmetic geometric progression. Shortly it is known as the AG. A simple problem, that is it is known as the arithmetic geometric progressions. We discussed this problem in details. It's a very peculiar type of series. Solution. By observation, it is seen that is the 1, 2, 3, 4 dot is a and 1 x square x to the power cube dot is a z. So we can say that this series, this term of that series is a product of AP and product of GP. So it is a AGP. So it is a AGP, arithmetic geometric progression. Now I have to find the sum. Therefore, let S is equal to what? 1 plus twice x plus 5x square plus 4x cube plus dot up to infinity. If we multiply this by x, then we get x into s. This equal to what? We get x plus twice x square plus 5x cube dot up to infinity. Considering this is number 1 and number 2, then If we subtract this, that means 1 minus 2. Then we get taking x, 1 minus x. This equal to what? We get 1. This minus this, we get x. This minus this x squared. This minus this x cubed. Dot 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 infinity. It is seen that this series is a ZP. That series is a ZP. And given modulus x is less than 1. Also given modulus x is 1. This is the sum of the infinite terms. So we can write this 1 minus x is equal to what? Here is equal to 1 into r is less than 1. Therefore 1 minus x divided, that is 1 by a by 1 minus r, that means x. Since we know in GP f of infinity is equal to what? A by 1 minus r, where r is less than, modulus r is less than equal to 1. That is the concept of the infinite sum of infinite series in GP. So we can write this as equal to what? 1 by 1 minus x whole square. That is the sum of this series. Next we are going to discuss some important sequence which is known as a harmonic progression, harmonic series. Harmonic series is generally denoted by AHP, harmonic progression. Now, what is the harmonic progression? Harmonic progression is nothing but reciprocal of AP series. Here, reciprocal of each term in AP series form a harmonic progression. That is, suppose we consider 1, 4, 7, 11, dot 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 is an A. Reciprocal of this number is equal to what? 1 by 1, that means 1. That means 1 by 4, that means 1 by 7, that means 1 by 11, dot dot dot. It is A. That means each term of AP, their reciprocals are these. So this is AP, then their reciprocals form is P. To find the nth term of ASP, always we can try to find the nth term of ASP. After this, if we take reciprocal of nth term, then we get nth term of harmonic progression. Here Tn, that is AP, Tn, that is nth term of AP, is equal to what? A into n minus 1 into A plus n minus 1 into B. Here in case A is equal to what? B is equal to what? 3. Therefore we get 1 plus n minus 1 into 3. This equal to what? 1 plus 5n minus 3. This implies 5n minus 2. That is the nth term of AP. Now, nth term of ASP, that is Tn of ASP. Tn of ASP is equal to what? Tn of ASP is equal to 1 by 5n minus 2 is the nth term of ASP. That is not 11, that is 10. This is also 10. Very simple question we are going to discuss. This is in ASP. Therefore, given find T7 of the series, first we have to check this series. Solution. Let the reciprocal of these numbers are 3, 23 by 8, 11 by 4, dot dot dot. Therefore, 23 by 8 minus 3 is equal to what? 23 minus 24 by 8 is equal to minus 1 by 8. And 11 by 4 minus 23 by 8 is equal to 8 Therefore 22 minus 23, this is like 1 by 8. These are same. Therefore it is and therefore given series is in ASP. That's the ASP. This thing is written nothing but ASP. Now T7. Therefore AP T7 of AP is equal to what? A plus 6D is equal to A means what? A means 3 plus 6 into D means 1 by 8. This is equal to 24 minus 6 by 8. Therefore we get 18 by 8. This is equal to what? 9 by 4. Now ASP T7 is equal to what? Reciprocal of this number, then we get 4 by 9 is the correct result. That is the T7 of this series is equal to nothing but 4 by 3 equations. Let first two terms of ASP are 1 and 1 by 5, then find 10th term of ASP. Here in AP, T1 equal to what? 1 and T2 is equal to what? 5 in AP. Therefore, T10 AP. T10 is equal to what? A plus 9D is equal to A means 1 plus 9D means 4. That is 5 minus 1 equal to 4. Therefore, the 10 is 37. Therefore, ASP T10 is nothing but reciprocal of this, that is 1 by 37 is the T10 term of ASP. That is the last problem of today's class. Before going to discuss the question, one note is given. Note 1, no terms of the ASP is 0. If term of ASP is 0, then term of AP is equal to 1 by 0, that is undefined. So no terms of ASP is 0. Number 2, most problem of ASP are shown in AP. After this, we can take reciprocal. So most problem of ASP are solved in AP. No ASN, sum of n terms formula in case of ASP. The question is given, if A, B, C are in a GP and satisfy this condition, then X, Y, Z are in number 1 ASP, number B AP, number C GP, number D AGP. Which option is the correct option? Solutions. Let A to the power 1 by X, B to the power 1 by Y, C to the power 1 by Z is equal to K. D is equal to what? A is equal to K to the power X, B equal to what? K to the power Y, C is equal to what? K to the power Z. Since given that A, B, C are in GP, therefore we get B square is equal to A. See, that is the condition of A, B, C, GP is equal to what? B square is equal to A, C. Therefore we get B square is equal to what? K to the power Y whole square is equal to A is equal to what? K to the power X into K to the power is equal to Z. D is equal to we get twice Y is equal to X plus Z. That is X, Y, Z in AP. This implies we get twice Y is equal to X plus Z. Therefore we get twice Y is equal to X plus Z. Therefore X, Y, Z in AP. That is the very important concept. So we get X, Y, Z is in A, P. So correct option is this is the correct option. That is the very most important question in JEE and CEE, also board exam. So we stop today. Thank you. Okay.